Good. Okay, welcome to Klein's Geometry. Today we're going to look at angle relationships in circles. Again, we've looked at several, but this is lesson 11.5. So we're going to find the measure of angles formed by lines that intersect circles and use that angle measure, those angle measures to solve problems. We've already looked at interior angles of a circle. We know if it's a central angle, that the angle measure and the arc measure are the same. We know if it's an angle inscribed, if the vertex is on the circle, it's going to be half the intercepted arc. Now let's look at a few more ways angles and circles can relate. So if we've got a tangent and a secant that are intersecting on a circle, so what that means is the vertex is on the circle, and here's my tangent, and here's my secant. So notice it's still got a vertex on the circle. And because it does have a vertex on the circle, just like the interior ones, it's still going to be, this angle is half of this arc. Just like it was in the last lesson, when you had maybe an angle that did this, and I told you this angle was half the arc. Now I'm saying even if it's like this and it's a tangent, the angle is still half the arc. So don't worry about that, but let's get it drawn in your notes and realize this angle, half of the arc. So it's still same. So now let's find some arc measures using this. If we want to find the measure of angle STU, we're going to find an arc measure, or angle. I see here's S to T to U. I want this angle. I see this arc is 166, so I just take half of it. And I know the angle is 83 degrees, okay? So just times 1/2 equals the angle. Now here I know an angle. I want to find arc, S to R. And I see tangent, secant. Well, I have the vertex on the circle and I can see an arc in here. So 71 times 2 gives me the arc, 142 degrees. So angle times 2 to get the arc divided by 2 to get the angle. Same as we were doing when we had the interior. Now, let's look at the next situation. Let's say we've got two secants, two chords, but what's happening is they intersect inside the circle. Now we know whatever this angle is, this is the same because vertical angles are congruent. Not exactly in the center, so it's not going to be the same. These are different arc measures. Not a vertex on the circle, so not the 1/2, but each of these angles is 1/2 the average, or is the average of these two arcs. So whatever this arc is, if we're looking to find the average, we just take half of this arc plus this arc, and we'll get that angle measure, and that one because they're the same. Okay? So if they intersect at some random point in the circle, just find the two arc measures and average them. Take half. Okay? So inside the circle, we want to find angle AEB. I look over here. I'm looking for this angle. I see here's an arc, and then where they intersect, here's my other arc formed by these two vertical angles. So I'm just going to say, and here's my measure, here's my measure. I average them, I add them up, divide by 2, and I know my angle measure. So write down your formula, add the two arcs, divide by 2, and you've got 126 degrees, and that would be both this angle and this angle. So inside the circle, if the angles meet inside the circle, the vertices are in there, just average the two arc measures, and you've got it. Now what if the angle is outside the circle? Notice we could have 3 possible situations. Maybe I've got a secant and a tangent, but I've got this vertex is outside my circle. I might have 2 tangent lines. Vertex is outside the circle. I might have 2 secant lines. Vertex is outside the circle. In every case, inside the circle, you added the 2 arcs and divided by 2. If the vertex is outside the circle, you're going to subtract the 2 arcs and divide by 2. So this arc minus this arc, divide by 2. This arc minus this arc, divide by 2. This arc minus this arc, divide by 2. So you're always just subtracting your arcs, and obviously subtract the smaller one from the larger one because these measures must be positive. Here's some examples. Find the value of x. Okay, vertex is outside the circle, I think subtract. So here's my big arc, 87. Here's my little arc, 7. 87 minus 7 is 80. But I know I have to divide by 2, so I'd end up with 40 degrees here. Okay, so big arc minus little arc, divide by 2. Here, same thing. I've got my vertex is outside the circle. This is my bigger arc. This is my smaller one. So I'm going to say 200 minus 74 divided by 2 and end up with 63. So vertex outside the circle, big one minus small one, divide by 2. Vertex inside the circle, big one plus small one, divided by 2. So this is fun. Here's a good example, real world. Company logo, very cool. Arc FG, so if I'm going to label these things, you got to know what's what. F to G is 108 degrees. LJ, right down here, is 12, and we want angle F to K to H. So I see the vertex is outside the circle. So I think no problem, outside, subtract and divide by 2, and you just simply say, I'm going to 108 minus 12 and divide that by 2, and you know, there's your angle measure, 48 degrees, no biggie. So, the 3 things you learned in this video. If you've got the vertex of an angle on a circle, then that angle is half the arc. Or you could say the arc is twice the angle. If the vertex is inside the circle, add your arcs, divide by 2 to get your angle. If the vertex is outside the circle, subtract your arcs, divide by 2 to get your angle. So enjoy these types of problems, and I will see you in class.